Hey, what's up everyone? Professor Wolverine here, and today I'm going to be teaching you about U-Substitution.
You talking to me?
No, not U-Substitution. U-Substitution. It's one of the most important integration techniques in calculus. Now, what is U-Substitution? Well, it's the integration analog of chain rule. So, antiderivatives are two derivatives, as U-Substitution is the chain rule. Now, throughout the course of this video, I'm going to be interchanging the terms antiderivatives and integrals because, as you know from the fundamental theorem of calculus, they are essentially the same thing.
Why don't you explain this to me like I'm 5?
No, I'm not going to explain it to you like you're 5. Look, if you need it explained to you like you're 5, you shouldn't be here, okay? Go watch cartoons or something.
Why are you the way that you are? Honestly, every time I try to do something fun or exciting, you make it not that way.
Look, man, I'm just trying to help people with calculus. Could you please either just stop interrupting or leave?
I hate so much about the things that you choose to be.
This is the last time I'm going to tell you! Get out of here right now!
Please, goodbye. Just please goodbye. Sorry about that. That guy is such a Does anyone know what's with that guy?
Must be killing you now that Michael is smarter than you.
Okay, so now I'm going to explain to you why U-Substitution is like reverse product rule. So, suppose h of x is equal to f prime of u of x times du over dx, where h, f, and u are just some functions. Now suppose we want to find... Okay, want to find. Suppose we want to find the integral of h of x. Now the integral of h of x is equal to the integral of f prime of ux times du over dx. Just because h of x is equal to this, so of course this integral is equal to this integral. But now, what's the integral of this? Well, think about chain rule. It's just equal to f of u of x plus a constant. Right? Think about it. If you differentiate this with respect to x, you're just going to get this thing right here. And that's why U-Substitution is just like reverse chain rule. Okay, now sometimes u of x, right here, is called the inside function. And this thing right here is the derivative of the inside function. Now sometimes when U-Substitution is done, it looks a little bit different. Let me explain. Sometimes when people do U-Substitution, they'll cancel out the dx's and write that this is equal to the integral of f prime of u du, which is of course just f of u plus a constant, where u is some function of x. But you can't leave it as u. You have to replace it with whatever the function of x is. Now, if you're confused by anything I just said, don't worry about it.
Forget about it!
Forget about it! Let's move on to an example. Okay, so now for an example. Recall that if we have a function, h of x, which we want to integrate, then the idea behind U-Substitution is to express it in this way. U of x sometimes is called the inside function, and then this right here would be the derivative of the inside function. Okay, so now suppose the function we want to integrate is h of x equals x e to the x squared. Okay, so if you look at it, it looks like the inside function, the u, should be equal to x squared. So let u equal x squared, then du over dx is just equal to 2x, right? Right? Tell me that's all right.
All right.
Okay, so what does that tell us? That tells us that this thing right here is equal to 1 over 2 du over dx. And this thing right here is equal to e to the u, right? So this thing right here is equal to e to the u times 1 over 2 du over dx. Okay, so I'm going to call this smiley face because you're all so happy to be here. Now we can cancel out the dx's, and then we get the smiley face equal to the integral of e to the u over 2 times du. Now what's the integral of e to the over 2? It's just e to the u over 2 plus c, right? Now what's u? Well, u is x squared, so we have to replace it. So this is equal to e to the x squared over 2 plus a constant. So this is the integral of this function right here. And you can check this by just differentiating it, and I encourage you to do it.
No! God, please, no! No! No!
Now you can see that if you take this function right here, take this, differentiate it using chain rule, you're going to get exactly this. So that's why it looks like a reverse chain rule. Okay, remember, I respond to all questions, so if you have any questions about this, I understand it could be a bit confusing, let me know in the comments. Hey, I can see you dozing off, pay attention to me. Remember, if you have any questions about this, let me know in the comments. I'll reply, I swear to God.
I swear to God. Swear to me!
Holy who let you in here? Alright, I swear to you, I swear to Batman, I will reply. They're really intense, you know that?
Swear to me!
Okay, so let's look at this example. So first, what should the u, or the inside function, be? So I'm going to let u be equal to this right here. So u equals x cubed plus 1. Then, what's du over dx? It's just 3x squared, right? Okay, so what does that make x squared? X squared is just 1 over 3 du over dx, right?
Affirmative.
So that means this thing right here, which this time I'll call sad face because at this point you probably just want to leave. So sad face right here is equal to the square root of u times 1 over 3 du over dx. Now we could cancel out the dx's, right? So I'm just going to erase these. And we get this. So what's the integral of this? So you have to use the power rule. So it's equal to 2 over 9 times u to 3 over 2 plus a constant. Now remember, u is x cubed plus 1, so this is equal to, it's equal to 2 over 9 times x cubed plus 1 to the power of 3 over 2 plus a constant. And again, to check this, all you have to do is take this function, differentiate it to check that you get this function. Attention, please!
May I have your attention, please?
Okay, so let's do one more. This is the tricky one. The integral of tan x. So what should u be? What is the inside function? Let me give you a hint. Tan of x is equal to sine x over cosine of x. So now pause the video, think about what u should be.
The limit does not exist. The limit does not exist!
What are you talking about? What limit? Where do you see a limit? Oh my god!
Saltwater stings. See?
Hey!
Okay, did you give up or did you find it? Okay, so there's not many options, right? Okay, so I'm going to help you out. So u should be cosine of x. Then du over dx is equal to minus sine of x, right? So I'm going to call this thing me, that's me. Okay, so I'm equal to minus 1 over u, du over dx, dx. Now we can cancel out the dx's, and we just get minus 1 over u du. And what's the integral of that?
Say it louder!
It's just minus log u plus c, or as you might say, minus ln u plus c. Where u is cosine of x, so this is just equal to minus ln cosine of x plus a constant. Ta-da! Okay, so thanks for coming. I hope you found this helpful. If there's anything in this video that you didn't understand, please let me know. I'll clear it up in the comments. Share this with 10 friends for a chance to win $1 million. Okay, that chance is 0, but still. 0, it's still a chance. It's still a chance.
You are technically correct. The best kind of correct.
If you have any suggestions for videos, let me know, please. Also, like, comment, subscribe, and share. If there's anyone you know that needs help with calculus, please share this video with them. If you enjoyed the video, please hit thumbs up.
Booyakasha!
If you didn't enjoy it, please hit thumbs down. It's good either way. Okay, so U-Substitution is an integration analog of chain rule, but there's also an integration analog of product rule, and it's called integration by parts. I'll be doing a video on that in the near future. Though I actually already have a video on integration by parts, and you can check it out. But I'll put up a video in the near future with more examples. Until next time, I'm Professor Wolverine, out.